discuss relative velocity. Relative velocity. So I will try to explain relative velocity in a very simple way. Now, for relative velocity, whenever you are dealing with relative motion or relative velocity, minimum three bodies should be there. So first, there should be at least three bodies here. Minimum three bodies should be there. So first you have to understand which three bodies or four bodies or five bodies are involved for which you want to find out the relative motions. Three bodies must be involved, or minimum three bodies, minimum three bodies should be involved. Should be involved. For example, suppose this is our Earth. This is our Earth. And two bodies are there. First is this A. Okay? This is A. It is moving with some velocity. Suppose in this direction, it is moving with a velocity V1. V1. And this is A. There is another body. This is second one. This is B. B. And it is moving in this direction. And its velocity is V2. V2. Okay? V2. So here three bodies are A, B, and Earth. Okay? So Earth, ball A and ball B, they are the three bodies. Now, what is the velocity of A with respect to Earth? First, that is V1. That is V1. So what is this V1? This is velocity of A with respect to Earth. This is velocity of A with respect to Earth. And it is moving in the plus positive X direction. So I'm going to write it as plus V1 here. Plus V1. So first is velocity of A with respect to Earth. Second is this velocity of B with respect to Earth. Second is velocity of B with respect to Earth. How much it is? That is plus V2. Why plus? Because this is also moving in plus x cap direction. So I'm assuming this direction is plus x cap direction. Okay? Plus x cap direction. So what will be the velocity of A with respect to B now? So what will be velocity of A with respect to B? What is the formula for this? So formula for this here is A is here, B is here. Who is missing? Which third body is missing? That is Earth. So A is present here, B is present here, Earth is missing. So formula will be VA with respect to Earth minus VB with respect to Earth. So whatever is the missing body that you are going to place here. So velocity of A with respect to B will be velocity of A with respect to Earth minus velocity of B with respect to Earth. And it will be simply V1 minus V2. V1 minus V2. This will be. In most of the books, you find out they write like this, that VAB, velocity of A with respect to B, is VA minus VB. But remember this, here E is hidden, and this is velocity of A with respect to B. So this is VAB. Now, suppose you want to find out velocity of B with respect to A. Velocity of B with respect to A. So here, what will be velocity of B with respect to A? So B is here, A is here, Earth is missing. So what it will be? This will be velocity of B with respect to Earth minus velocity of A with respect to Earth. And it will be equal to, you can also write it as in books you will find out they are writing like this, VB minus VA. And how much it will be? What is VB? VB is V2 minus V1. So this is velocity of B with respect to A. ठीक है? Velocity of B with respect to A. Second thing is, if you take minus common from here, then what will be VBA? VBA. This will be, if I take minus common, this will be minus common, then this will be V1 minus V2. And what is this V1 minus V2? That is VAB. So I can write velocity of B with respect to A. This will be equal to velocity of A with respect to B with minus sign. So this is another correlation. Okay. So by using this type of formulas like this one, or this one can handle one-dimensional or 1D relative motion problems. Okay. But always remember that there will be three bodies involved here. One body is A here, another is B, and third is Earth. Now, I will give you different examples here. Can I go to next page? Please write it. Please note it down quickly. Next. Am I audible?
Yes, sir.
Yes, sir.
Good. Now, suppose this is a car here. This is a car here. So with this example, I will try to give you all the possible. So here, suppose this is moving, this is car A, and this is moving with 10 meter per second. Okay. Second is this, second car is this. This is second car. And this car is moving in this direction. Suppose this is 15 meter per second. And these are arbitrary numbers I'm choosing. Okay. And they are moving on the earth. They are moving like on the earth. So they are moving towards each other. So here, try to understand what will be VA, or you can write it as VA with respect to earth. Because it is moving in plus direction, so this is plus 10. Remember this. Plus 10 meter per second. And this is moving in negative x cap direction, so VB, this will be VBA, BE, and this will be minus 15 meter per second. Meter per second. So what will be the velocity of A with respect to B? So that will be VA minus VB. So this will be 10 minus 15. So this will be 25 meter per second. Meter per second. Second, velocity of B with respect to A. Directly I can write this will be with minus sign, minus 25. So this will be VB minus VA. So this will be VB is minus 15 and minus 10. So this will be minus 25 meter per second. This may be the case. Okay, this is the first case. Here. Now second, if I convert their direction, change their directions like this. Second case, suppose this is moving in this direction. This is I call it as 10 meter per second. 10 meter per second. And here it is moving here with 15 meter per second. Meter per second. So in the second case here, this VA, because it is moving in the negative direction, so this will be minus 10 meter per second. and VB, this is moving in plus x cap direction, so VB will be plus 15 meter per second. So what will be VAB? So here Earth is, ठीक है ना, Earth is hidden. This is VAE, this is VBE. So VAB will be VA minus VB. So how much is VA? That is minus 10 and minus 15. So this will be minus 25 meter per second. And what will be VBA? VBA will be VB minus VA, and that will be equal to, this is plus 15 minus 10. So this is 25 meter per second. So basically, with the help of this formula VAB and VBA, you can handle any problem related to relative motion. ठीक है, in 1D cases. In 1D cases, you will assume this direction as plus x cap direction. So velocities which are in this direction in plus x cap direction, they will be positive, and this direction is negative minus x cap. So velocities in this direction, they will be with negative sign. And after that, apply these formulas. So 1D cases you can handle with the help of these examples or these formulas. Only the single formula of VAB is required to solve any of the question. But remember this, here there should be at least three bodies. Okay, so you should be, whenever you are doing, you are solving a question, you should be very clear in your mind which three bodies are involved here. So it may be any difficulty level, but if you are very clear that these three bodies are involved and these velocities are given with positive and negative sign, you write them, then you can easily handle any of the numerical problem. So this is the first case. Okay? Please note it down. Then I will go to the relative velocity in 2D cases. Can I go to next?
Yes, sir.
Next is relative motion between, one of the very important problem is relative motion between rain and water, or relative motion between man and rain. This is, ठीक है ना, this will be. So this is one of the very famous problem. Now I will discuss different cases which are possible here, but first I want to write here, this is VR. VR means velocity of the rain. What is this? This is velocity of the rain, of the rain with respect to earth, with respect to earth, earth. This is the first one. Second is VM, velocity of the man, velocity of man with respect to earth, earth. And third, velocity of the rain with respect to man. So this is velocity of rain with respect to man, with respect to man. So here three bodies are involved. Which are three? One is rain, man, and earth. ठीक है, अर्थ, मैन एंड रेन, these three bodies are involved here. So when I'm writing VR, this is velocity of rain with respect to earth, velocity of man with respect to earth, velocity of rain with respect to man. So what is the meaning of this? How will you decide what is the velocity of the rain with respect to earth? So velocity of rain with respect to earth will be observed by the observer when he is at rest. ठीक है ना? So VR, velocity of rain, velocity of rain with respect to earth, with respect to earth will be observed, will be observed by the man, will be observed by the man when he is at rest, when he is at rest. This is important. If you are standing on the earth, you are not moving. Try to understand. You will observe the actual direction of the rainfall. The direction in which rain is falling, you can observe the actual direction of the rainfall. If you are standing, ठीक है ना, you are standing on the earth, you are not moving, then you will observe this one, velocity of the rain with respect to earth. Only then you can observe this. And when you are going to observe this, velocity of rain with respect to man, ठीक है, this is observed by the man, this is observed by the man or observer, by the man when he is moving, when he is moving with respect to earth, with respect to earth, when he is moving with respect to earth. So when he is moving, you are going to observe VRM, velocity of rain with respect to man. And when the person is at rest, he is going to observe velocity of the rain with respect to earth, because when you are standing on the earth, you are in the same frame. You and earth, you are same. You are same reference frame. So these are the important aspects before discussing this problem. So which three bodies are involved here? One is rain, rainwater that is falling. Second, observer who is moving. Third, earth on which this person is moving. So these three bodies are involved. When the person is at rest, he will observe the velocity of the rain with respect to earth. Second, when he is moving and whatever he is observing, he is observing velocity of the rain with respect to men. Is it clear up to this point? Next. Yeah, before this. Now, what will be the velocity of the rain with respect to men? This will be equal to, who is missing? Earth is missing. So velocity of the rain with respect to earth minus velocity of the man with respect to earth. So simply I can write velocity of rain with respect to man, that will be equal to VR minus VM. VM. This will be. Always keep this thing in your mind. Bring this VM on this side. And what will be VR? VR will be VM plus VRM. Always remember this line. And if you can draw this vector addition, if you can draw this vector addition, then you can solve these questions very easily. In every type of problem, you have to draw this equation in the form of vectors. VR equal to VM plus VRM. VR equal to VM plus VRM. Please note it down. So VR is equal to VM plus VRM. I'm going to solve all these questions with the help of this. This will be. So what can be the first case? Case 1, case first. Three cases or three or four cases may be here. Suppose this is our Earth. This is our Earth. And a person is moving to the right. What is his velocity? This is he's moving with a velocity Vm. This is the velocity of this person Vm. He's moving on the Earth. This is the velocity with respect to Earth. So this is Vm. You can write like this. Second first case, suppose he is observing that rain is falling like this. ठीक है ना? This person is observing that this is VRM, velocity of rain with respect to man. When he is observing that rain is coming from his backside and falling like this. So this is the direction of the rainfall. Now, suppose this angle is theta. This angle is theta. Now, what you have to find out here? You have to find out VR, actual velocity of the rainfall. Second, actual direction of the fall of the actual direction of the rainfall and magnitude of that. You want to find out VR vector and direction of VR vector. These two are your objectives. So what you are going to try here? You have to add these two vectors VM and VRM so that may be created. You want to create this VM and VRM. Look at these two vectors. It is like this, it is like this. So how you are going to add? You are going to add like this. You are going to add like this. So how I am going to add it? So it will be like this. This is VRM. Sorry, VM. This is VM. Try to understand. I want to add VRM. So I can draw like this. This is VRM. So here it will be VRM. VRM. VM vector. This is VRM vector. What will be VR? VR will be the vector sum of these two. So this will be the direction of VR. This will be VR. If you look at this direction, this is VRM. So I'm going to draw this perpendicular from here. So this will be theta. This will be theta. Now you want to find out VR and you want to find out the angle of VR. Suppose you can choose this angle from here. Suppose this is the angle you want to find out, phi. So magnitude of VR and this phi angle you want to find out. How? How you are going to do this? First, bolo beta. Resolve this VR in the perpendicular direction. Resolve this VR in this perpendicular direction. So what it will be? ठीक है? What it will be? This will be here. If you resolve this VR here, this will be VR cos theta, and in perpendicular direction, this will be VR sin theta. So what will be VR sin theta or sin phi? Sorry, VR sin phi. I'm resolving this. This VR is here, and second component will be here. So this vertically downward component VR sin phi. This will be equal to how much? This will be this VRM cos theta. This will be VRM and this will be cos theta. This will be VRM cos theta. Is it okay? Second, resolve this. This is this vector VR. Resolve this vector like this. This is VR cos phi. Cos phi. So VR cos phi will be from here to here. How much it will be? This is Vm plus this. This will be Vrm sine phi, sine theta. Vrm sine theta. So what is this? This is phi. So Vr cos phi. Vr cos phi will be from here to here. Here. This will be Vrm sine theta plus Vm. So you can write it as Vm plus Vrm sine theta. In actual question, in numerical problems, you don't need to write like this, because here some angle will be given, and with the help of that angle, by using trigonometric ratios, one can easily find out this phi as well as this v here. You can very easily find out in actual problems. But if they give you in the form of expression, it will be like this. Now square and add these two equations. Square and add 1 and 2 together. So this will be VR square. And on this side, this will be sine square phi plus cos square phi. So this will be sine square phi plus cos square phi. And on this side, this will be VRM cos theta square plus this will be VM plus VRM sine theta and whole square of this. So this will be 1. So this will be VR square. On this side, this is Vrm square cos square theta. Here Vrm square sin square theta. So this will be Vrm square. Okay? Plus Vm square. So plus Vm square plus 2 times Vm, Vrm and sin theta. Make the square. This is square here. So if I write it Vr, then it will be square root. So what will be Vr? Vr will be square root of this. This will be. This will be Vr. So what will be Vr? Vr will be Vrm square plus Vm square plus this. So I'm not saying that you have to remember these formulas, but you have to learn how you are resolving these vectors. Okay? Try to understand how you are resolving. If you know how to draw these pictures, then you can solve this question. Try to understand, if I resolve this VR in vertical direction, then this vector will be this one. This will be V, this is VR, this will be VR, phi is here, so this will be VR sine phi. Okay? So this will be VR sine phi. Now try to find out how again you can create. So this vector VRM is there. You can also resolve it in this direction. So this will be VRM cos theta. You have to learn how you are going to create these equations. Second, if you resolve this vector in this direction, and it will be like this. This will be VR cos phi. And this VR cos phi will be equal to Vm plus Vrm sine theta. In this way, you can create these two equations, and numbers will be there with you. You can easily solve this type of equation. Second, if you want to find out this phi, divide these two equations. If you divide, VR will cancel out, and tan phi,
So,
that will be just 1 second, beta. Vrm cos theta divided by Vm plus Vrm sine theta. Yes, please, beta. This is the direction. So from here you can find out phi. Yes, beta, please.
sir, I can't understand how to find these equations.
How you are going to resolve a vector? Suppose there is a vector like this. You are having a vector like this. This is VR vector. This is VR vector. and I'm saying this angle is phi. This angle is phi. So how will you resolve this VR in this direction? What will the component of VR in the horizontal direction? This component of this VR, that will be VR cos phi. So this component will be VR cos phi. Second, its vertical component will be this one. And how much it will be? This will be VR sin phi. Okay. So here I have done this. This is VR. I resolve this and I resolve like this. Now I find out the length of this VR cos phi. VR cos phi is equal to this plus this. This is VM plus, if you resolve this, this is VRM. If I resolve this VRM and this angle is theta, then this will be VRM sine theta. This will be how much? In this triangle, this will be VRM sine theta. Okay? Plus VM. So I created this equation. If you consider this, so this VR resolved in vertical direction, this will be VR sine phi. VR sine phi. And another way is to find out is by resolving VRM. VRM is resolved in this direction. So this will be VRM cos theta. So I write this equation VRM cos theta. So in this way, ठीक है, first you are going to create this triangle. ठीक है, so here triangle is very simple. VM is here. This is VM. Second, you are going to add VRM to this. So this is VRM. You are added this one. This is VRM. This angle is theta. Theta. So what will the direction of VR? VR will be in this direction. This will be automatically VR. VR. And this is VRM. So in this way, first you have to draw this triangle. And then you can create this type of equation. Theta is given. Theta is given. Is it clear what I'm saying?
Yes.
Or I can give you a very simple example. Suppose, suppose this person is moving with a velocity 4 meter per second. I'm just taking simple numbers, or 5 Vm. This is 5. Try to understand. 5 meter per second. Any unit you can choose, whatever unit is suitable. Second, he is observing that rain is falling in this direction. This is VRM. VRM. Okay? And suppose this is 4. 4. And angle with which here, this angle, I'm saying this angle is 30 degree. Suppose this angle is 30 degree. So this will be 30 degree. So these are very simple problems. So I draw a perpendicular from here and I'm saying this angle is 30 degree. 30 degree. What is this? This is VRM. This is VM. So what will the direction of VR? VR, VR will be in this direction. So numerically solving this type of problem is very easy. This is VR. I want to solve this. So first you know how to draw this. So VM is here, VRM is here, this is 30. You're saying that find out the actual velocity of the rainfall. Okay, I can easily find out how. Can anyone tell me how can you find out? It is a very simple problem. When number is given, you just tell me what will be this side. This is 4. Okay, this is 4. I'm saying this is A, this point is B. AB is 4, VRM is 4. So what it will be? This will be 4 cos 30. This will be 4 cos 30. ठीक है ना? 4 cos 30. Cos 30 is root 3 by 2. So this will be 2 root 3. Length of this side is 2 root 3. This side is 5. What will be this one? This will be equal to how much? This will be VRM. Yes, beta, VRM sine 30. Sine 30 degree 1 by 2. So this will be equal to 2. So what is this side? This side will be now 5 plus 2, 7. So this side is 7. How much is this side? This side is 2 root 3. Can you tell me what will be VR? VR will be simply square root of kitna? 2 root 3 square. 2 root 3 square plus 7 square. This will be the whatever meter per second or whatever unit you are choosing. So this will be VR. This will be VR. Is it okay? Hello?
Yes, sir.
Now, if someone asks you what is the direction of this, suppose direction of this with the vertical is this. I'm saying suppose this direction of this actual rainfall with the vertical, I'm saying this is could be anything phi. You want to find out this phi. Now I can find out phi. What is this sine phi? Sine phi or tan phi, whatever you want to find out. So tan phi from this triangle, can anyone tell me? Tan phi will be, this angle is phi, so this will be 7 upon this base. Base is 2 root 3. So with the vertical, phi is equal to tan inverse 7 upon 2 root 3. This will be the answer. So these questions may look like very difficult, but they are very simple. What you have to do, if rain is falling from the backside, like this, for the moving person is moving in this direction. Person is moving in this direction. This is VM. He is observing that this is VRM at 30 degree. 30 degrees. What you have to do, you should know that, you should remember that VR is equal to VM plus VRM. Create this type of vector situation. So VM is here. This is VM. Okay? So I have to add VRM. This is VRM you can draw. And this will be VR. VR. Okay? This will be VR. And this is VRM. So you should know how to draw this. This angle is 30 degree. Now each and every calculation that is very simple. Class 10 students who know sine theta, cos theta, tan theta, he can easily solve this question now. Just you have to use these trigonometric ratios. By using trigonometric ratio, find out VR. So what he is going to do, he will give you two parameters. Out of these three velocities, he will provide you two. And he will ask you to calculate the third one. So this is first case. Hopefully it will be very clear to you all. Can I go to next case?
Yes, sir. Previous slide दिखा दीजिए.
Okay, beta.
Thank you, sir.
Please note it down also. Then I will go to next case. Sorry. Second case may be suppose this person is moving in this direction, VM. VM. And he's observing that rain is falling like this. This moving person, he's observing the rainfall is like this. Okay, this what is this? This is because he's moving himself. This person is moving himself. So this is VRM. And I'm saying suppose this angle is 60 degree. Now I am saying please find out VR, actual magnitude of the rainfall and the direction of the rainfall. This time I'm not going to do that algebra because I have explained you how with the algebra you can do, but there is no need of any algebra here. You can directly do this. You just know how to do the vector addition. Whenever this type of problem is there, so I'm giving you numbers. Suppose this number is 5 again, or this is 5. You are taking this number as 4 or something. ठीक है ना? Or you can do the reverse also. You can take it 10. Whatever will be required, I will change these numbers if required. This type of situation is there. So what is my equation which you have to remember? Bolo, VR equal to VM plus VRM. Don't forget this. In any situation, don't forget this. You have to write, you have to remember in this way. So first I'm drawing this VM. This is VM and you are saying this is 5. So this is VM and this is 5. Okay. Now you have to add VRM. You are going to add VRM. So how you are going to add VRM here? बोलो बेटा. How you are going to add VRM? इस नंबर को थोड़ा चेंज कर लो. That will make this practice easy. Make it 10 and make it 4. You can choose any number, but just for your understanding, I'm making it like this. So I'm taking it as 10. बताइए. This is VM vector. You have to add this VRM. So where this point is A, suppose this is B, where should I add this vector? This vector should end here. Try to understand. So this is 4 or something and it is here. So in this way you are going to add this. This is VRM and this angle is 60 degree. This is 60 degree. And how much is VRM? VRM is 4. So first you have drawn this vector VR plus VM. So what will be VR? VR will be this. This will be VR. VR vector. Can anyone find out this VR from this data? This is simple problem of trigonometric ratios now. You just want to find out VR. How can you find out? Any one of you can solve this problem. Draw this perpendicular. This perpendicular side will be how much? This will be 4 cos 60. ठीक है ना? तो ये कितना होगा? This side will be 4 cos 60. So how much will be 4 cos 60? 6 cos 60 is 1 by 2. So this will be simply 2. So this side is 2. What will be this side? This one. How much it will be? This will be 4 sine 60. So this will be 4 sine 60. So root 3 by 2. So this will be 2 root 3. So this side will be 2 root 3. 2 root 3. I'm telling you the simplest method for solving this type of problem. So what will be this side? Now you are going to draw. I want to find out how much is this. Total was 10. This is 2 root 3. So this side from here to here, that will be 10 minus 2 root 3. And this is 2. So what will be VR? Pythagoras theorem. So VR will be simply square root of, this is 2 square plus, this will be 10 minus 2 root 3 and square of this. That will be VR. Is it okay with everyone? That will be the VR, magnitude of the actual rainfall. actual velocity of the rainfall with respect to Earth. This is the velocity of rain with respect to Earth. Second, you want to find out the direction. So either if you want to find out this, suppose this is theta. So what will be tan theta? You can find out any angle. You give me any angle, I will find out. Sorry, that will be tan theta. Tan theta. This, this is perpendicular. Tan minus 2 root 3 divided by base. Base is 2. That will be tan theta. In this way, you can find out. This is case 2. This is second case. That is possible. So first, for a moving person, either rain will fall from the behind. Second, ठीक है? Second case may be when rain is falling on his face. ठीक है ना? When rain is falling on his face. This is the second case. Is this case clear to everyone?
Yes, sir.
Hello. Now third, there is a third and last possibility. Case 3. It is like this. The person is moving on the earth. He is moving in this direction. Suppose with some was 8 meter per second, or I write it as Vm. Vm. And Vm is how much? I say it is 8 meter per second for units. This is Vm. And what he is observing? He is observing third possibility. First possibility was like this. Second was like this. Third possibility is he is observing that rain is falling vertically downward. What this person is observing, that rain is falling vertically downward. So this is VRM. I call it as 3. And I keep it as 4 meter per second. 4 meter per second. And you have to find out VR and direction of VR. This is the third case. So again, write that equation. VR is equal to Vm plus VRM. So this is Vm. This is 4 meter per second. This is Vm. Second is VRM. I created this. This is VRM. And how much is this VRM? That is 3 meter per second. So what will be VR? VR will be this. Sum of these two is VR. So in this case, what will be VR? VR will be simply from the Pythagoras theorem, 3 square plus 4 square. So that will be 5 meter per second. If they ask you the direction with the vertical, suppose it is having a theta direction, then tan theta, that will be 4 upon 3. So theta will be tan inverse 4 by 3. 4 by 3. This will be. So only these three cases are possible in rain and man, relative motion between rain and man. So this is a specific problem in many exams. ठीक है ना? This question, this type of question they have asked. So these three cases are possible. If you understand these cases, what is the simple rule? Remember this equation. Second, draw this type of diagram and try to complete this vector addition. And after that, this is just a trigonometric ratio problem of class 10. Hopefully you will be clear about it.
Sir, the previous slide, please. Done, sir.
Okay. Next. Next is relative motion of swimmer in flowing water or flowing river. Relative motion of swimmer and flowing water of a river. Flowing river. River water. This is another important problem of relative motion in 2D. Okay. So first, I'm writing this is velocity of man or swimmer. This is man or swimmer. So what is this? This is the velocity of the swimmer. Velocity of swimmer, of man or swimmer, with respect to earth. With respect to earth. First. ठीक है. Second, velocity of the river water, VR. This is velocity of river water. Velocity of river water. Water. With respect to earth. Earth. Third is velocity of man or swimmer with respect to river water. So what is this? This is velocity of man or swimmer with respect to river water. So here again three bodies are involved. Okay, one is man, river water, flowing river water is there, and third is earth or its banks. Two banks are there. Okay, they are representing earth. So three bodies are involved. Man, swimmer is there. Flowing water is there. Third, banks of river. ठीक है, banks of river. You can consider them earth. So these three bodies are involved. So what will be the velocity of the man with respect to river? What will be the velocity of the man with respect to river? So that will be velocity of the man with respect to earth minus velocity of the river with respect to earth. In simple way, I can write velocity of the swimmer with respect to river, water, velocity of the man with respect to river water. That will be velocity of the man minus velocity of the river. So bring this negative term on this side. So velocity of the man, ठीक है ना? Velocity of the man, that will be velocity of the river plus velocity of the man with respect to river. ठीक है? So this is the velocity of the man with respect to earth. So actually velocity of the man with respect to earth, this will be observed by a person who is standing on the banks. On the stationary banks, an observer is there and he is going to observe, okay, in which direction this man is moving. The swimmer is swimming in which direction. So VM, direction of VM, you can observe from the earth, from the banks, which are stationary. Okay, you can observe from here. River water is going to flow in the direction of the river. Second, and there will be a direction in which this person will try to move with respect to the water. That will be VMR, velocity of the man with respect to river. So different cases may be there. So there may be different cases. Please note it down. Please. Case 1. So I divide all these cases. Okay.
Done.
So case 1. Suppose I have divided all cases into two parts. First case will be, suppose velocity of the swimmer with respect to river water is greater than velocity of the river. First case is this one. So here this is a river. Flowing river. Water is flowing in this direction. And what is the river water flow? That is VR. VR is here. A swimmer starts his journey from this point. This is one point on this bank. Okay? On this bank, this is a point. And I'm drawing another point, vertically opposite point on the opposite bank is this. This is B. Okay? This is B. This is VR. Now, what is the objective of the swimmer? Swimmer will start his journey from here. Swimmer want to start his journey from here, and he want to reach at the opposite bank. So what is the objective? Swimmer starts his journey from A, and want to, from A, capital A, from point A, and want to reach reach at the opposite end, at the opposite end at point B, at point B. This will be. So what you want to observe from the earth, if you are standing on the earth here, your observation from the earth is, you want to move this swimmer, you want to see this swimmer to move in this direction. ठीक है ना? From the earth, you want to see that this person should move in this direction, only then he will reach at B. So what will be the direction? This should be the velocity of the swimmer, velocity of the man with respect to earth. So what it should be, this will be the VM. Try to understand. You want to observe this because you want this swimmer to start his journey from A and want to reach at B. You want to see him at B. So automatically from your point of view, the swimmer should move like this. So this will be the velocity of the man with respect to the earth. This will be. And what is my formula which I have given you right now? That is VM is equal to VR plus VMR. VR plus VMR. VR plus VMR. Sum of these two vectors, that should be VM. Try to understand, VR is in this direction. And you are saying VR plus this vector is this one. So what is VR? VR will be somewhere here. I'm drawing this VR vector. VR will be here. This is VR. River is flowing in this direction, so I cannot change this. I cannot change this. So where should this swimmer should swim? In which direction he should swim? So swimmer is going to swim at an angle theta with this direction AB. So this should be the direction in which swimmer should swim with respect to river water. MR. This will be VMR. So this should be the angle. This should be the angle. So basically for this purpose, swimmer should swim at an angle theta. At an angle theta with respect to AB. To AB. With respect to AB. He should swim like this. Is it clear to everyone what I am saying? Hello?
Yes, sir.
Yes, sir.
So what will be this angle? If someone asks you what is this angle, so out of these three, VR, VM, VMR, he is going to provide you two quantities. Suppose he is providing you VM and VR. VM and VR, or this VMR or VR, any two he may provide you. So suppose he provides you these two, so automatically what will be tan theta? I can write tan theta. Tan theta will be VR upon this VM. VM. This will be. If he gives me two other quantities, he provides me this VR and VMR, then I can use sine theta. If he provides me VM and VMR, I can use cos theta. So just depending upon the two quantities which he is going to provide me, I can find out theta. This is the first one. Now second, what will be the time taken by this person to cross this river? Time taken by the swimmer to cross the river. So time to cross the river. To cross the river. You are going to tell me. What will the time to cross the river? That will be simple. That time is t. How much, suppose width of this river is d. D is the width. So time taken will be d. Okay. Try to understand on this side. You can use this side or this side. Which component is going to take you up in this direction? That suppose this is x direction, suppose this is y direction. So you have to consider the velocity in the y direction. So either you use this component of mr, ठीक है ना, in this direction, ठीक है ना, so or a component of this m in this direction, or component of this side in this direction. So component of this side in the y direction is simply Vm. So either I can write Vm, or I can write d upon what is the component of these two vectors in this direction. Vr is in perpendicular, so its component in vertical direction is 0, and component of mr in this direction will be Vmr, mr cos theta. This will be. VMR cos theta. So by these formulas or by this simple analysis, you can find out the time to cross the river. In this case, when he want to cross this river, ठीक है ना, in a perpendicular direction. He want to cross the river in a perpendicular direction. So he has to swim in this direction with respect to the river water. Only then he is going to reach here. Only then he is going to. So throughout its motion, velocity of the man with respect to earth, it should be in this direction. In this direction. Can you tell me one more thing? ठीक है. Suppose next question is, suppose the swimmer want to cross this river in minimum time. Suppose the swimmer want to cross this river in minimum time. ठीक है. This was the first one. This was my first question number A. First, he want to cross in this direction, so you want to find out this angle theta. Second, you want to find out the time in which he will cross this river in perpendicular direction. Next question is, he want to cross the river in a minimum time. Now he is removing this restriction. Now he don't want to move. He don't want to cross this river in perpendicular direction. He remove this condition. And he want to cross this river in minimum time. So what it will be? Can you, from here, can you tell me when he is going to cross the river in minimum time?
We have to give values for cos theta,
Yes,
maximum.
beta. Very good. So what is T? So if he want to cross the river in minimum time, try to understand from here this d upon VRM cos theta. To cross the river in minimum time, cos theta, because it is cos theta is in denominator, it should be maximum. Cos theta should have maximum value, so it should be +1. Cos theta is +1 means theta is 0. It means theta is 0, beta. So this angle should be 0. So this swimmer can cross this river in minimum time if VMR or this swimmer is moving with respect to water in this direction. If this swimmer starts his journey in this direction with a VMR, only then he can cross this river in the minimum time. So next is B is swimmer want to cross. Swimmer want to cross the river. Want to cross the river in minimum time. In minimum time. Next is this. So this is next objective of the swimmer. ठीक है? So first I'm going to draw this river again. I draw this line. Swimmer is going to start from here, from this point A. And he want to cross this river. After crossing this river, he may be anywhere. Just he want this time minimum. Time minimum. So for this purpose, what he has to do, he has to make theta 0. So the swimmer with respect to river water, the velocity of swimmer with respect to river water should be in this direction. Theta should be 0. So here theta is 0. Theta is 0. ठीक है? So this is VMR. VMR plus VR. And that will be equal to VM. So I have to add this VR to VMR. So I'm adding this. This is VR. VR. Okay. So what will the resultant velocity of this as observed a person from here? Then this swimmer is going to move in this direction. This will be VM. From the earth, person is going to this observer will observe that swimmer is moving in this direction. And where this person will reach on the opposite bank, he will reach somewhere here. Here. So this point is B. Now, after crossing in minimum time, this person will reach here at point C. So this horizontal distance, this this distance that is covered in the x direction from B to C, this is called as drift. This is called as the drift. So in this minimum time, the swimmer is drifted along the flow direction by a distance BC. You also have to find out this drift. You also have to find out this drift. So can you find out this angle theta? What will be this theta? First. What will be this theta beta? Theta कितना होगा बताओ? This will be, बोलो, any theta, any angle, whatever is needed for you. Suppose I start with tan theta. So what will be tan theta here? Look here. Tan theta will be VR upon VMR. VR upon VMR. MR. Suppose VR is not given. ठीक है, suppose VR is not given, so I can write in place of VR, I can also write this is VM square minus VMR square divided by VM R. So at least two velocities he is going to provide me, and from those two velocities I can always find out this theta. I can always find out that theta. Second, what will be the drift? Can you find out the drift? Drift.
VR into T.
That will be, this is VR. ठीक है, look at this equation. You have to take the x component of this. So x component of this will be Vm sine theta. This will be Vm sine theta. Your answer is correct, beta. Vm sine theta component of this in this direction into time t. Time t. Or whatever student is saying, x component of this side. So VR, ठीक है, VR is in this direction, that is okay. MR is in perpendicular direction, so it doesn't have any component. So this will be VR into T into T. And what will be T? T कितना होगा? Try to understand. What will be T? Time to cross or minimum time, that T. For crossing, it has to move in perpendicular direction. Cross, ठीक है ना, it has to cover how much distance? D distance. ठीक है, from here to here, how much distance is traveled in y direction? That is D. Component of this Vm in the perpendicular direction, this Vm cos theta. So this will be Vm cos theta or D upon, this is y component of this, y component of this, these two is VMR. That will be VMR here. That is VMR here. ठीक है? So X will be, substitute this. This will be Vm sine theta. And in place of T, D upon Vm, that will be D upon Vm cos theta. Vm. So Vm is cancelled out. This will be d sine theta. So I didn't find my answer from this side. So second one, that will be x. That is Vr. And here t will be d upon Vmr. D upon Vmr. You can use this. So Vr upon Vmr into d. This will be the drift. Vr upon Vmr. Vr upon Vmr into d. From here you can also find out this. Vm will cancel out and this will be d tan theta if you look at d tan theta. And tan theta if you look here, okay, that will be Vr upon Vmr. So this is just a trigonometric ratios. Vr upon Vmr. What you have to do, you have to make the correct diagram. You should be very clear when you are drawing the diagram. If you can draw this diagram very correctly and you understand the meaning of VMR, VR, VM, then any time you can solve the question. So this is the first case beta of this swimmer, okay, who is swimming in the river. He want to cross the river. So two possible cases are here I have discussed. For the first case, when velocity of the swimmer with respect to river water is greater than VR. So first case maybe he want to cross this river exactly in the perpendicular direction. So you can find out the time to cross the river and the angle at which he should swim so that he can cross the river in the perpendicular direction. Second case maybe he want to cross this river in the minimum time. If he want to cross the river in the minimum time, he has to travel in the perpendicular direction. So VMR will be in this direction, not at an angle. So VMR will be in this direction, but in this process, time taken will be minimum, but the swimmer is going to drift with respect to B. So that drift you can also calculate from here. That drift you can also calculate from here. So this is, okay na? So this is the first case I have discussed. In the next class, I will discuss the second case of this relative motion, as well as I will discuss some of the questions related to relative motion so that you can understand these concepts in a much better way. Are you people following me?
Yes, sir.
Yes.
Yes, sir.
ठीक है बेटा. चलिए, okay बेटा. Thank you very much. Good night.
Thank you, sir.
Thank you.
Welcome.
Thank you,
Thank you,
sir.
sir.
Welcome बेटा.